Today, we start Module 2, Analysis of Algorithm Efficiencies and Brute Force Method. Then, this module, we will have several classes, about 3 classes. The first one, Part A, Efficiency Measurements and Growth Functions. The first one, Part A.1 Selection Sort. All right, let's look at our problem number 4, Sort and Add Array. This is our first sorting algorithm. In this class, we will learn many, 4 or 5 or 6. We will learn that many sorting algorithms. The first one, let's look at the problem now. Given an array. All right, unordered, definitely. We want to make it from unordered to ordered. How to sort it in ascending order? That's simple. So the description of the problem, very simple. The problem type, sort. Here I also give you the reference in the textbook. So if you want to study, you can read those pages. Now let's work. Let's try to find a solution on it. Work and analysis. Let's do the work first. Here I want to start with general problem solving method, thinking. Find an algorithm from our experience. So in our science, so when we study science, we have to learn the new knowledge, but we always do the, we always try to create new methods based on our experience. So here we do that. What is our experience? For this class, we have not learned a lot of things. We only learned, small number of concepts, methods. Let's look at what we have learned so far. We just solved the minimum problem, right? That's in our experience, the minimum problem. So the question, how to find a solution based on the minimum problem? So for this new problem, for this class, this is the first time we look at this problem. So it is a new problem. How do we use our experience to give us idea to solve it? That's the point. All right. When we do that, we need to explore properties. We need to understand this problem well to find some important properties. All right. Let's look at how to work it out. Here we do some assumption. We take a special view. So this view is, we do this assumption. If the array is sorted, so we look at from that view. For the same problem, there are many different views we can look at it. This sorting problem, next time when we try to find a second solution, we will change our view. Many different views to look at this problem. So now we look at from this. Assume the array is sorted. What property can we find? So that's this view. We assume distinct elements for convenience. So then we do not need to consider equal, unequal, So, but the difficulty pretty much the same. Yeah. Later, after we make this assumption and we solve it, then it is very easy. We can factor in the equal case easily. Yeah. All right. So assume the array is already sorted. So we have all the elements in ascending order. Now let's do this critical observation. Let's consider the whole array, then A0 is the minimum. That's a simple fact, right? But if you observe this fact, you are very close to your solution. All right, so let's look at another round on this simple fact. All right, next time, if we look at the remaining elements, other than A0, because we already processed it, so we leave it out. Look at the remaining elements, then A1 is the minimum of the remaining elements, and so on. Okay, so now you can see if we know how to find the minimum, so we can apply it here, apply it here. Every step we apply our solutions for the minimum problem. Then can you solve the whole sorting problem? Right? Yeah. So that's the basic idea. Let's implement it. After we have this idea, we need to fix all the details and get a solution. Now let's do it. Let's draw this diagram. Okay. So we have all the locations ready for our elements we want to arrange. All right, so at the beginning, it's empty. All right. Then, how do we put our first element? Right? Find the minimum. We just call the solution of the minimum problem. That function will return us the minimum value. Then we place it in the first location of the result array. Here, let's view this, empty locations result array. All right. Here, let me introduce a concept here. In order to make our discussion easier, we want to create a new concept. Now, what's that concept? When we put that element in this position, we call this element is in place. This is our new concept, in place. Based on your intuition, that's simple, right? Simple understanding. The exact meaning of this in place, the element is placed at the position when the array is sorted. Look at the condition. When the array is sorted. Okay? So you imagine if the array is sorted, what the right position for an element in the initial array. Okay. In that situation, we use this InPlace concept. That's the reason at the beginning we make this assumption the array is sorted, right? Because in that case, in that arrangement, we can use this InPlace concept. Okay, here. The first element is in place. All right. Next, then for the remaining element, can we call that function another time? It will return us the minimum of the remaining subarray and we place it in place. So another in place. Then next one in place. Okay? All the way to the last element in place. Can we get the whole array sorted? Yes. Because we have this simple fact. When all the elements are in place, the array is sorted. Yeah? All the elements are at their right position when the array is sorted. In place. Yeah. So now the solution is that obvious. Okay? Yeah. All right, after we get the solution, let's do some simple analysis. Analysis is very, very simple. How many comparisons do we use? That's easy. Yeah. To find the first element, to make the first element in place, we use n-1 comparison, yeah, based on our discussion for the minimum problem. Okay, yeah. Next one, n-2, and so on. Okay. The second to last, okay, 1. The last one, we don't need to do any comparison. Okay, the last one, because there is no place, no other place this one can choose. Only one place it can go, no comparison needed. Yeah. So in that case, we add up all these n-1 numbers by some formula, we get the answer. All right. Now, after we get this answer, I'd like you to think about it. Another concept, one concept we discussed last time, best case, worst case, average case efficiency. Can you look at that? Yeah, but for this question, it is very easy. So I think you should be able to get the answer for the best case, the answer for the worst case, and the answer for the average case. Yeah. I will tell you that in my following videos, yeah, because we need to use that. Yeah. All right, so let's finish this one first.